Dear children, welcome to my first session of Chapter 12, Arrays and Structures. Take a look at this declaration statement, int mark semicolon. Here I have declared a variable mark as integer. Dev C++ allocates 4 bytes of memory for this variable mark. I can use this variable mark to store only one integer value. But suppose I have to deal with several integer values, say 5 values. Then I have to declare 5 variables which are of integer type, like this: int mark1, mark 2, mark 3, mark 4, mark 5, semicolon. Each of these variables are allocated random memory locations, each of size 4 bytes. Since all these variables are going to hold integer values, won't it be convenient if I have one variable which can hold all the 5 values? For example, suppose there is a variable marks which has 5 locations, each of which is of integer data type, and each location is allocated with 4 bytes of memory. Now, instead of having 5 variables, mark 1, mark 2, mark 3, mark 4, mark 5, I will declare one variable called marks as follows: int marks, and within square bracket 5 semicolon. This means marks is an integer variable of 5 locations. By this declaration statement, I have created a fixed number of sequential memory locations which can store values of the same data type. This type of variable is called as an array. An array is a derived data type. An array is a continuous group of memory locations of same data type referenced by a common name. An array is a continuous group of memory locations of same data type referenced by a common name. Here, all these 5 locations are referenced by the common name marks, and each of these locations are of int data type. In this declaration statement, int is the data type, marks is the array name, and 5 is the array size. So, data type space array name, and within square brackets array size semicolon. This is the syntax for declaring an array. The memory allocated for one location of int data type is 4 bytes in Dev C++. The number of bytes allocated for this array marks is calculated as 4 bytes into 5 locations, which is equal to 20 bytes. Next, I will show you how to initialize this array. That is, how to store values in an array. The easiest way to initialize an array is in the declaration statement itself. Int marks 5 is equal to, within set brackets, you give the values separated by comma and end with semicolon. These values will be stored in each of the locations of the array marks. After initializing the array, our next task is to access the elements for processing. Firstly, let me try to print the values stored in this array marks. If I write a cout statement, cout marks, this is the output which I get. So, cout marks does not print the elements of the array marks, whereas it prints the address of the first location. By giving only the name of the array, we cannot access the elements of the array. In order to access each and every element of the array, you should use the positional value of each of the elements. Each element has a positional value starting from 0. These values 0, 1, 2, 3, 4 are called as indices or subscripts. The index or subscript of an array always begins with 0. Each element in the array is referenced by using index or subscript. Now I will show you how to print all the elements of this array marks. For that, you have to write 5 cout statements, and along with the name of the array, you should mention the index of that particular element. So marks 0 refers to the first element of the array. Marks 1 refers to the second element, and so on. These cout statements will give the following output. You can see that the elements are printed vertically. That is because of the endl over here. If I had omitted the endl, all the elements would have been printed horizontally one after another. You have learnt about iterative control structure. Iteration means performing an action repeatedly for a certain number of times. So instead of writing several statements which are similar, because only the index values are changing, I will remove all these cout statements and place one cout statement within a for loop. Iteration means looping. So here I am going to use a for loop. For counting the subscripts 0, 1, 2, 3, 4, I take a counter variable I as integer, and then in the for loop I initialize I with the value 0 because the starting index is 0, semicolon, I less than 5 because the last index is 4, which is less than 5, semicolon, I plus plus. And within the body of this for loop, I place one cout statement, cout marks I endl semicolon. This for loop will generate the values 0, 1, 2, 3, 4 as the values for the counter variable I, which will be used here in marks of I for every iteration of this loop. Therefore, using a loop, you can easily access each and every element of an array. Accessing each element of an array is called traversal. Traversal is the process of accessing each element of an array. In this example, I have initialized the array during declaration itself. But most of the times, we want to initialize the array by getting input from the user during runtime. So if you want to get the values for the array from the user, you can write a cin statement inside a for loop like this, cin marks I, and also you can place a message above the for loop for the user to know how many values to be input. So here I have given the message as enter 5 values. When I execute this coding, first the message enter 5 values is printed, and because of the endl, the cursor waits in the next line waiting for input, and as I give the first element of the array, it will be read by cin and stored in marks 0 because the initial value of I will be 0. So 67 is stored in the first location of index 0, and for each iteration as I give the input, the values are stored in the corresponding index positions. So using a loop, you can access elements of an array and also you can initialize the array. Price is a float array of 3 locations. Char city 6. City is a character array of 6 locations. How many bytes are allocated for this array? Price. Since each location of this array is of float data type, each location is allocated 4 bytes. So the total bytes allocated for this array will be 4 bytes into 3 locations, which is equal to 12 bytes. And for the array city, since city is a character array, each location occupies 1 byte. So the total number of bytes allocated for this array will be 1 byte into 6 locations, which is equal to 6 bytes. Here I have declared a character array bubbles of size 5. To initialize this array during declaration, in the declaration statement itself, you write equal to, and on the right hand side, within set brackets, you give the elements separated by comma. Since this is a character array, each element is a character enclosed within single quotes. The elements A, E, I, O, U will be stored in each of the locations of this array bubbles. Even I can group together all these characters and initialize in this manner. Char bubbles 5 is equal to AEIOU within double quotes. Recall that a sequence of characters enclosed within double quotes is called as a string literal. A string is a sequence of characters enclosed within double quotes. By default, string literals are automatically added with a special character null at the end. So, the compiler will automatically add the null character to mark the end of the string. When you are initializing a character array with a string literal, you should be careful while giving the size of the array, because you should provide an extra location for the null character. So in this declaration, the size of the array 5 will be insufficient. I should give as 6 to avoid an error. Once again, look at these two declaration statements. If you initialize this character array by the first method, you can give exact size, that is 5. If you are initializing by the second method, that is if you are grouping together all the characters as a string, then you should provide extra location for the null character. To avoid this confusion, you are allowed to omit the size of the array. This is also correct, because the compiler will by itself calculate the number of locations needed, and along with it, it will take an extra location for the null character. So we need not bother about giving the size of the array when we are initializing the array during declaration. So here also I can omit 5 because the compiler can calculate the size by counting the number of elements within this set bracket. Also note that even if you initialize a character array with a string, each character is stored in an individual location of the array. When I print this array bubbles, cout bubbles, I get this output, that is the string itself is printed, AEIOU. When I do the same with a numeric array, I get the output as the address of the first location of that array. Here marks is an integer array, and when I say cout marks, the address of the first location of the array is printed. And whereas bubbles is a character array, and when I say cout bubbles, all the characters are grouped together and printed. I have already discussed the fact that if you want to access the elements of a numeric array, you should mention the index. But for a character array, index is not needed to access all the elements of the array. So there is difference in the way in which a numeric array and a character array are treated by the compiler. Look at the following array declarations. These arrays have only a single row. That is, all the elements are stored in one row. When an array has only one row, they are called as one-dimensional arrays. An array can also have several rows. Here the array num has 3 rows and 4 columns. The subscripts 0, 1, 2 are the row subscripts, and the subscripts 0, 1, 2, 3 are the column subscripts. The array num can be declared as int num 3, 4, semicolon. That is, this integer array num has 3 rows and 4 columns. When an array has both rows and columns, it is a two-dimensional array. In this two-dimensional array, int is the data type, num is the array name, 3 is the number of rows, and 4 is the number of columns. Therefore, data type space array name, and within square brackets the number of rows, and within another set of square brackets the number of columns, followed by semicolon, is the syntax for declaring a two-dimensional array. Since this array num is declared as int, each location occupies 4 bytes. So the number of bytes allocated for this array is calculated as 4 bytes into 3 rows into 4 columns, which is equal to 48 bytes. Next, I will show you how to initialize this two-dimensional array. On the right hand side of this declaration statement, and since there are 3 rows in this array num, you should have 3 elements. Each element is itself an array. The elements 1, 2, 3, 4 within set brackets are the elements for the first row, comma, 5, 6, 7, 8 within set brackets are the elements of the second row, again comma, 9, 10, 11, 12 within set brackets are the elements of the third row, and all these 3 rows must be given within another pair of set brackets. Observe how the elements are stored in this array num. In the first row, 1, 2, 3, 4. Second row, 5, 6, 7, 8. Third row, 9, 10, 11, 12. To access an element in a two-dimensional array, for example, to access the element 7, you should look up the row subscript and the column subscript for this location, which is 1, 2. So I write a cout statement, cout num, that is the name of the array num, 1, 2. So to access an element in a two-dimensional array, you should mention both the row subscript and the column subscript. That is the row index and the column index along with the name of the array. This cout will give the output as 7. To access each and every element of this two-dimensional array, you have to use nested loops. Here I take 2 counter variables I and j as integer. First I write the outer for loop, which counts the row subscripts, and within this outer for loop I give an inner for loop which counts the column subscripts. For counting the row subscripts I use the variable I, and for counting the column subscripts I use the variable j. And within the inner loop you can give the cout statement, cout num I j, that is I is the row subscript and j is the column subscript. This coding will give the following output. You can see that all the elements are printed horizontally, one after another. Usually, two-dimensional numeric arrays are used to solve matrix problems. So most of the times you may be required to print the array in a rectangular form like this. To get this form of output, here in the inner loop, after printing each element, you should give a tab space so that you will get horizontal spacing after each element. The inner loop will print one row, and after the completion of one row, here after the inner loop, you should give a new line so that each row is printed in a separate line. In this example, I have initialized this two-dimensional array during declaration itself. You can also initialize this array by getting input from the user during runtime. For that also, you use nested for loops. In the place of cout, you can give cin. But remember that with cin, you cannot use escape sequences. Next, I will give you an example of two-dimensional character array. Char names 3, 6. Names is a character array of 3 rows and 6 columns. This is a two-dimensional character array. Let us see how to initialize this array. So here in the declaration statement on the right hand side, within set brackets, I have given 3 elements. Each element is a string within double quotes. The first string Anu is stored in the first row along with the null character. The second string Priya is stored in the second row ended with null character. The third string Banu is stored in the third row with the null character. To access an entire row, for example, to access the second row, cout names 1. So it is enough if you mention only the row index. For the second row, the row subscript is 1. So names is the name of the character array and within square bracket 1. This will give the output as Priya, which is the string stored in the second row. And to access an individual character, for example, to access the character A, you have to mention both the subscripts. The row subscript is 2, the column subscript is 1 for this location. So cout names 2, 1. This will give the output A. Here names is a two-dimensional character array. A two-dimensional character array is also called as an array of strings. An array of strings is a two-dimensional character array. The size of the first index denotes the number of strings, and the size of the second index denotes the maximum length of each string. In this example, the size of the first index is 3, which gives the total number of strings, and the size of the second index is 6, which denotes the maximum length of each string. The next topic is memory representation of two-dimensional arrays. Normally, two-dimensional arrays are viewed in a rectangular form of rows and columns. But in the memory, the elements of a two-dimensional array are arranged in continuous memory locations like a one-dimensional array, like this. The first element 1 is referred by the index 0, 0 because 1 is in position 0, 0. 2 is 0, 1. The element 3 is in 0, 2. The element 4 is in 1, 0. 5 is in 1, 1. And 6 is in 1, 2. In this representation, the elements are stored row by row. That is 1, 2, 3 is the first row and 4, 5, 6 is the second row. This type of memory representation is called row major order. That is, the elements are stored row by row. Therefore, in row major order, the elements are stored row by row in continuous memory locations. That is, the first row and then the second row and so on. Next, look at this arrangement of elements. The index of the element 1 is 0, 0, 4 is 1, 0, 2 is 0, 1, 5 is 1, 1, 3 is 0, 2, and 6 is 1, 2. Here the elements are arranged column by column. 1, 4 is column 1. The elements 2, 5 make column 2 and 3, 6 is of column 3. This type of memory representation is called column major order. In column major order, the elements are stored column by column in continuous memory locations. With this, I come to an end of this session. Let me once again review all the topics that I taught you in this session. What is an array? An array is a continuous group of memory locations of same data type referenced by a common name. Arrays are of three types: one-dimensional arrays, two-dimensional arrays, multi-dimensional arrays. A two-dimensional character array is also called as an array of strings. Accessing each element of an array is called traversal. To access each element of an array, you have to use index or subscript. The index or subscript of an array always begins with 0. Row major order and column major order are the two forms of memory representation of two-dimensional arrays. That's all in this session. Thank you, children.